The 11.4 is related to friction and air resistance. So let's have the basic idea of friction. We focus on activity 11.8. Now you may try to perform this experiment using the textbook and your workbook. Now you try to overlap the pages of the textbook and your workbook, just like the diagram here, and then you try to pull out the workbook and the textbook as well. You'll find that it is very hard to pull the books apart. And of course, you can have the other activity like you try to put a coin on the surface of your desk, and then you try to give a short push, okay, to the coin, and see whether the coin moves or not. If it moves, okay, you find that it stops immediately. So why we have this kind of observation? Because there are friction between the object and the sliding motion. From the previous example, you'll find that if you try to pull the textbook and the workbook apart, the pages between the books with a contact force here, and the contact force will reduce the motion for what you want to do. On the other hand, you find that another activity, you push a coin on the surface, there will be a friction which opposes the motion of the coin, which makes it slow down and stop immediately. So that means friction is actually a force, a contact force, which exists between the surface in contact. Now there will be a lot of examples, like using your mobile phone by your finger sliding on the screen and make some maybe you tap on the apps or you play some games on your mobile phone, and this is related to again friction and the sliding direction, which are opposite each other. Another example is you park a car on the roadside. The friction will support the car with avoiding it going down the slope. Another example is about you playing a sport like baseball, and you try to reach the point you want, and the sliding direction with a friction opposite to its direction. So, how to measure the friction? Okay, again, we need to use the spring balance as the friction is a kind of force. We try to tie up the spring balance with a weight, and then we give a pulling force on it. And you find that for certain value on the spring balance, you can make the weights to move. However, if you increase your pulling force, the weights will start to move. And please draw these two arrows above it into your textbook that when the pulling force is larger than the friction, the weights will move to the direction that you apply the pulling force. In this case, it will move to the right because the pulling force is directly on the right, which is larger than friction. Just like what we have learned before, this is actually an unbalanced force, because in unbalanced force, the weight will keep at rest or stay in a motion, in a uniform motion. However, it is stopped originally. That means if you have an unbalanced force, a pulling force larger than its friction, it will move to the right hand side. So lastly, we have friction will be defined as opposed of the sliding motion of an object, and of course there will be a surface in contact with. So friction is a contact force and opposed to sliding